Yeah, we made it! Woo! The fundamental theorem of calculus! Yeah! Ladies and gentlemen, we finally made it to the fundamental theorem, emphasis on fun here. Fundamental theorem of calculus, which is quite simply, how do you get a definite integral? Well, there's a few things about this. This is the fundamental theorem because it definitely is another way of showing that how derivatives and integrals are related. It shows how to find the area. It is actually proven using the mean value theorem, that theorem that we don't do a lot with, but is kind of a building block for all these other things. So everything that's proven with the fundamental theorem is based off of the mean value theorem. That's where it all begins. So let's just do this quick. If you're going from A to B, the lower limit is A, the upper limit is B. And this is your antiderivative. All you have to do to find the area is to take and plug in to your antiderivative, or integral, first the upper limit, then the lower limit, and subtract them. That gives you the area between the function and the x-axis. That's it. That's the whole fundamental theorem. Let's do an example. So here's a quick example, and this is all you need to do. You've been taking integrals now for quite a while. And I hope you realize that, we'll simplify this. There's a number in the denominator. We don't really need to have that right there. You can always pull out a coefficient and or a number, provided that, this number is multiplied by every term inside of there. So we're just going to take the normal integral or antiderivative, whichever one you want to call it, like we normally do. So this is what you get. There we go. But what I want you to do, or a notation that we use, and I was taught to use just one bracket, but our book uses two. Let's just show that, hey, we're still going from 0 to 1. That's it. And then I want you to plug in the number 1 everywhere there's an x, and the number 0 everywhere there's an x. Now, that's not too hard, and all you have to do is you plug in the upper limit first, the lower limit second, and then make sure that you subtract these two. I'd like to make a really big point here. When it comes to the constant, that is super important. You have to have that for all indefinite integrals. For a definite integral, what happens when I subtract these? I have a constant, and then I have minus a constant. Every single time that you do a definite integral, the constant, whatever that is, will be subtracted out by the exact same constant. In other words, the constant will not matter, and you don't have to add it in a definite integral. In an indefinite integral, you must have that constant. In a definite integral, it subtracts out every time. So skip the plus c, or put it in if you like, but it's going to subtract out every time. The worst part of this is certainly just the basic math. You need to be able to do some basic math here to figure out what this is. When you have numbers like 0, that makes it especially easy. A lot of times if 0 is in there, just the fact that you're multiplying by a variable will probably let that side equal 0. So I realize the big fear for many is not being able to add or subtract or multiply correctly. And that is a valid fear. But if you're doing everything right, I'm going to look at all the steps. I'll give you partial credit for taking the integral correctly and plugging in the numbers and then getting the final solution. That will be part of it, but not the entire thing. Ladies and gentlemen, that's it. It's the same thing you've been doing. Just plug in your limits and subtract them. Always upper limit minus the lower limit. Here is yet another example of the fundamental theorem of calculus. I have a table of values giving me the value of g and, the x-coordinate that it's at. But then I'm asked to find the definite integral from 1 to 9 of the derivative of g. What do you think the integral will be when I integrate the derivative? Now, once again, I learned how to do it with just one bracket on the right-hand side going from 1 to 9. Our book tends to put 2 brackets. That's okay. What's really going to happen here is I'm going to take g of 9 minus g of 1.